Hi folks, this is Brad Vici from Northeast Kingdom Astronomy Foundation in northern Vermont, and this is astronomical image processing using freeware called ImageJ. And I've got the program open here. It just looks like a little taskbar with lots of little drop-down menus. And in previous videos I've shown a little bit about the program, how you open it. Here is the icon. It's a little brass microscope. And now I'm going to open up some files. Now I can do this in a number of ways. I can go to File and Open. I can drag and drop images to this little part of the taskbar. But what I'm going to do is an image import. We're going to import a sequence of images, and I'm not going to do the Rosette Nebula here. We're going to stay with bright nebulae, and I'm going to go down to the dumbbell. And if you've got a folder set up with your 3 or more frames, your red, green, and blue images, then you can click on any one of them and it will import them as a stack. And you just say OK here. It says 3 images. Yeah. And so this opens up the 3 images and it lays them on top of each other. And here they are. Boy, they are impressive looking, right? And you can tell there's 3 images because way up here it says 1 out of 3, M27. This is the blue filter. Then I'll go to the next image. There's the green filter. And there's their red filter. Boy, just almost nothing there. So an important lesson is that many astronomical pictures start out as pretty much a black frame with almost nothing to look at. And our goal here is to squeeze out the subtle detail that's actually captured here and create a beautiful image. This is how we do that. So the first thing we want to do is go and look at image and check which type. Now we normally take native 16-bit images, meaning that there's 2 to the 16th power, or 65,536 possible values of red, green, or blue. And when we calibrate these images, depending on how it's done, these were calibrated, these were taken robotically, they are automatically transferred to 32-bit images. So there's something like 4.3 million values for each channel. So we're going to leave it at a 32-bit image. That's fine. I just want to know where we are. And then I'll go down to Adjust Brightness and Contrast. And here we get a very small version of the histograms we talked about in previous videos. This is 0 is absolute black. This is absolute white. And way over here next to the black edge of the frame, we can see a little bit of gray plotted. And that means that this entire frame is almost entirely black. It sort of confirms what you can see. And what we're going to do is leave this minimum slider all the way over to the darkest of dark. And then we'll start bringing over the maximum, the second slider. And what I want to do is just move it over to see that, yes, indeed, there is something there. I don't want to leave it there. And then I'll compare my 3 channels. And they're roughly comparable. They're not exactly the same, but they're not ridiculously different than one another. Now you can see the image, the information about this image is right there. What you want to do is just make sure you've got something there. Occasionally we enter the wrong coordinates and we end up with 3 images of nothing because we didn't point the telescope at the right stuff. So the first thing we want to do is, ideally we would move this little bit of information over somewhere into the gray values where we can see it, and widen up that little peak of information. If we can broaden that, it gives us a greater ability to make careful, very fine adjustments. And so one of the ways we can do that is to perform a logarithmic stretch on this image. And what that does is brighten up the dim stuff without brightening the bright stuff. And it lessens the difference. So it lowers the difference between the brightest objects in the picture and the dimmest objects in the picture. And it kind of throws away some of the very black end of the scale, but that's okay because we got plenty of black. What we don't have is much in the way of gray value. So the way you do that is you go to Process. Now I'm going to stop here for a moment, and just a good form is I should go to File and say Save As and name this something. I'm going to save it as a FITS file, and I'm going to call it M27 first try. And that way, if I totally screw up this process and I ruin what I'm doing, I don't ruin my original data. I can always dump this and go back. Very good practice. The very first thing I really should have done was rename that. And you never want to use save, you use save as. If you use save, it actually overwrites the original file. So you use save as, and you can give it a new name. You call it Fred. You can call it, you know, yellow and green striped pickles. It doesn't matter, but name it something so that it won't ruin your original data. And now we'll go to Process, Math, and go down to Log. And when we do that, it's going to ask you, do you really want to do it? And it's going to say, hey, you can't undo this. So here's an important little detail. At this point, we're leaving science behind and we're getting into aesthetic. We're making pretty pictures. Once we start doing mathematical manipulations of the data, we can't go back and measure the brightness of a star. Let's say that when I process this image and I brighten it up, I find out that there's an asteroid that's moving through my frames. Wouldn't it be cool to measure the brightness of that asteroid and report that to someone? Well, you can't do science on images once you've had logarithmic stretching going on and you've mucked around with the original data. We're actually going to be changing the pixel values by doing this. So that's another good reason why you save your image as something else, so that at the end of this process, if I discover that there is a comet or an asteroid that's moving through my image frames, I can go back to my originals, which have not been messed with, and then I can try to do some photometry or provide those to some professional astronomer who could work with them. So I'm going to go ahead and say yes. I've already renamed my thing, and now what happens is my image turns absolutely black. Even the stars disappear. And if I now click on the brightness and contrast, what's happened is I've moved this little tiny spike way over into the middle, so we're down into the gray values here, but how come my picture looks absolutely black? And it will look absolutely black in all three channels. And the reason is that by some quirk of this program, these little slider gizmos get moved around and taken right off the scale. And so they get pushed off to the point where nothing's being displayed. And so what you can do here is you can mess around with them some more. And what I would recommend in this case is putting this just to the left of the plotted information, and not so far left that the sky begins to look milky. But, you know, we're not trying to make a pretty picture here. And this is a key point. Early in this process, what we're trying to do is not create a pretty picture. What we're trying to do is create a better histogram. That's why these little tiny histograms are pretty important. And I can go through these individual channels, and if these individual channels are really, really different, I can't handle them as a stack. So when we keep images in a stack, everything we do to one of them is done to all three of them. So this is a good point where I'm hemming and hawing, and I probably ought to separate my stack. So let's do that. I'm going to go to Image, Stacks, and then slide over and go down to Stack to Images. We want to convert our stack to individual images so we can play with them individually. And we'll do that. And now, boom, boom, boom. Now we've got these three images, the red, the green, the blue, can be now handled differently. They're still black and white, monochrome images. But now I can adjust the brightness and contrast of each one of them separately. I want to leave this all the way over. I want to make it as dim as I possibly can. That one's perfect. So let's move that over. Be done with it. Then we go to this one. Now we're going to use the green. And if I lose this brightness and contrast, I can close it and reopen it. Let's just do Image, Adjust, Brightness and Contrast. And I need to make sure that it knows, I'm adjusting this one. I have to highlight this one. And I'm sorry, if I double click on it, that makes it larger, so I want to highlight this one by clicking up here, and then I'll go to this brightness and contrast menu. And now notice that this one, the slanted line, the minimum line, is a little too far to the left. So I'm going to bring it over so that the background looks dark, and I can make finer motions with these little arrows. And then keep this one all the way over. And we'll say, okay, great. That one's beautiful. And now this one, I'll click on this one, and I can click on brightness and contrast. And again, see there's a gap in here. I want to get rid of that gap and make sure the sky doesn't look milky, because then when I put them together, I'm going to have this milky background that's going to be whatever color this filter is. This is the blue filter. And I can say super duper. Now those three images are wonderful. Now what I've got to do is take each one of them, and we're going to go back to a 16-bit image. So I'll convert it to a 16-bit image. Now this one is 16-bit, this one is not. So I have to take this one and say Image, Type, 16. I really want to be, when we do mathematical manipulations, when we do that whole logarithmic stretch, that has to be done on a 32-bit image. So if you start with 16-bit originals, you want to convert them to 32-bit in order to do any mathematical manipulation of the data so that there's no rounding up and rounding down errors.